just because I think what we're going to do now is bridge away from the L1 base into the agentic framework world. And when we get to talk to Eliza and Morpheus, we'll be sort of more deeply into real agentic framework building. But what I want to do with here is a little bit about taking some of these concepts we've been talking about here and thinking about how it really does interface with this AI agent world. Rohit, I think one of the things that's sort of interesting, having talked to you guys just recently, is you're looking at some of the fundamental sort of inefficiencies of blockchains, right? The fact that the network can become congested sometimes and others not, and the price of a transaction goes up and down and so forth. And you believe you can bring in AI solutions to solve that. Listening to what these guys have been saying, how do you see AI itself coming in and sort of adding a layer, if you like, on top of these blockchains and improving? And remember, we're always talking here about how do we solve the registry problem, right? So thoughts on how you could apply a technology like yours to this interoperability challenge and the efficiency challenges that we do see in blockchains?
Thanks, Michael. So I'm here to represent Cintara, and just like the set of panels before us, we are yet another L1 launching a set of foundations that you can call like an operating system for building agents on top of an L1. And within that work, we have started to encounter some of the issues that the previous panel was talking about. There are problems around network efficiency. My role is, as the head of research there, is try to look a little bit further ahead. That let's say these L1s come online, we have lots of agents, millions, maybe billions. What happens after that? I think that's one of the challenges that we are looking at. And we have something to learn from a few things that have happened in the recent past from that. In Web 2, I look at Alexa, for example. If you look at the Alexa marketplace, that's another example that we can learn from. And there are two patterns that we kind of concern ourselves a bit today. One, if you think about, we love to have, everybody loves to build agents and own agents. But underneath the agents, there is a fundamental resource that they are surfacing to the end user. And the resource is concentrated. That resource has concentrations, and that concentration will carry through into the agentic world that we are trying to create. And that concentration will create centralizations. So that is an issue to be aware of. The concentrations may come from data, compute, capital. It may come through other kinds of powers like IP and other algorithmic controls. Generally, the algorithmic controls go away over time. The other thing we've learned is that generally these agentic systems, they're kind of like a network, have settled into patterns over time that also give certain agents a lot more power over others. Typically, for example, in my own work, during my dissertation work, and then later at BBN, we have seen that the last agent in a chain usually holds a lot of power. A lot of things have to be coordinated or collected at that agent before it's sent out. And how do we try to work against that? One of the mechanisms that we would love to encourage in the registry and the work that Nanda is doing here is, instead of encouraging the choice of one agent in a chain, can we encourage people to spread their workloads across multiple agents that are not owned by the same entity? You can think of it as like real estate agents for an analogy. Could be even doctors in smaller practices. Can we incentivize the registry to spread the work across multiple agents? And would that lead to greater decentralization, greater equity in the ecosystems that we are trying to build? So these are some of the things we are thinking about. I will admit we have no answers at the moment, and we'd love to find some answers.
It's a fascinating way to think about it, right? Because in some respects, what we're doing here, we're saying we're starting at the base level here. We're trying to get this quilt figured out, the registries, and so forth. But thinking about this second-order effects of what's going to happen down the road, are we going to create an environment which one or two agents end up being overly powerful? probably is an important factor in the design considerations. Reminder to those of you who'll be participating in the workshops that we're having later on that one of the exercises here is to think about things that could go wrong and therefore the design considerations. So that's a really useful contribution there. And Caleum, just tell us a little bit about Coral, because you are essentially a network of agents and you're building a framework for that. How do you incorporate these issues into your design? And again, how are you guys thinking about how you build your bridge to the NANDA network, to the Hedera network, to the agents on Stellar, et cetera?
Thanks. That's a great question. I think you make a great point that you need to be wary of too much responsibility being kind of accumulated into a single agent. And I think that does tend to be sort of a pattern. I think many patterns just kind of naturally aggregate responsibility into a single agent. And it could be the last agent in a chain, or with a hierarchy, it could be the first agent. Coral, I think actually I resonate a lot with what Rob was saying earlier, where you kind of need to iterate between like building it and thinking it out, right? So we've been doing some building internally to kind of test out what's working well. And I think one pattern that is particularly strong in these cases is to have each of the agents actually running in their own loop. So instead of this workflow-like structure that has been kind of the state of the art so far, you have each of these agents running in their own loops. They're actually agentic. They have the autonomy to go and do whatever they want. And this way, I think it becomes very natural then to look at which agents have the most responsibility and just break them apart into two separate agents. I think it's a very useful pattern that I would promote that as well. In terms with interoperability, I think one other approach I would advocate for is having tool calls be the interface for where agents get to communicate with each other. Because one thing that's already common across agents, and a large part of this is thanks to MCP, is that it's very easy to make tools that are reusable by all the different agent frameworks and all the different agent structures. So if you have tools that allow the agents to send messages to each other, wait for each other to respond, and get the status of the other agents in their team, I think that's a very useful pattern as well.
Okay, and so maybe to round this thing out, just if you guys can have I should have told you this beforehand, listen to what they're saying and have just a quick, reflection on some of the new ideas. And I think particularly like this is, both of them are raising concerns about, agents becoming too powerful, and an interesting idea of breaking agents up. Like, how might that impact your frameworks and your thinking around this?
I don't think there's anything wrong with having agents with varying levels of influence or power in network. And here's why. I mean, we live in a society, and society has individuals and organizations that have a role to play. And I do believe that you're going to need agents that are acting like governors or policemen or regulatory enforcers and the likes. So to say all agents need to be equal and act the same is unfair, and because you are in fact constructing a new way of how the society is to operate. Without enforcers, without audit checkers, the system can be gamed. So you do want those. You want to make sure those who behave as the enforcers are governed appropriate. There is a framework for that. There's the auditability. There's the ability to ensure that they are behaving the way it's designed to behave. So that's just my opinion.
Okay. We need policemen on chain.
I think I disagree. And I forgot, I realized I introduced myself. My name is Garand Tyson. I do protocol research at the Stellar Development Foundation.
That was my fault, actually.
Yeah, my apologies. But no, I think especially in this context, global networks, whether that be like the network itself or just one single AI agent to rule them all, is a pretty dire situation. I don't enjoy monopolies. And I think we need to set the framework now such that the technology and the tools itself do not lend themselves towards monopolies. And so I think having something like MCP specs natively on-chain or some sort of decentralized way to have like MCP specs is very powerful. And you can actually do this on Stellar. Our smart contracts have on-chain MCP, which is kind of cool. But I also think that it's important to have as much diverse incentives as possible in the scenario. Because, for instance, if you have a monopolistic case where you have a single network or a single AI agent, then you have a single incentive, whatever incentive that one player has. And I think that could get pretty scary pretty fast. But I think the more disjoint your network is, and the more federated your network is, you can actually have people who have influence. Maybe not, the global influence is like a policeman or a governor agent, but maybe like a local government or a local policeman, which interplays with a slightly different other policeman that has higher level. And so I think for me, just both from a kind of game theory standpoint or from a technology standpoint, I just really want to focus on making sure that we have the most disjoint incentive structures we can, and not having like these kingmakers in our technology stack.
Okay. Had a little bit of polemics at the end. That was good, but you guys got to leave now. Sorry. So yeah, round of applause for Shyam and Garand. Good job, guys. All right, next victims. Shaw Walters from Eliza and